So in this particular video, we are going to cover all the important aspects with respect to mineral sources in India. Here we are going to discuss conceptual aspect, legislative policy aspect, location of minerals. This particular video is going to be one-stop solution for all the important aspects of minerals in India. Now here on screen, you can see questions that have been asked in previous years in UPSC CSE examination from minerals part. In 2023, there was question asked with respect to mineral that is used in manufacturing of fertilizer. In 2022, question was asked with respect to copper producing states in India. In 21, question was asked with respect to largest producer of coal. So we can see clearly a pattern that in 23, 22, 21, 20, 19, 18, likewise, every year there is at least one question that has been asked on minerals. However, certain years multiple questions have also been asked on minerals. So what we need to ensure? We need to ensure that at least these 1 to 2 questions that are coming from minerals, we should not make any mistake here. In this particular video, we are going to ensure that any question coming on minerals should be attempted. Moreover, I would also like to tell you that you can download entire notes of this particular session free of cost from our Telegram channel. Now, link for Telegram channel is given in description box. Also, in first pinned comment, there is a link for Telegram channel. You can go there and can download these notes free of cost. Now, first of all, most basic question is that what a mineral is all about. So, mineral, in very simple words, is a kind of naturally occurring substance. It is a naturally occurring substance which has a definite chemical composition. Mineral can be both organic as well as inorganic. Now, organic minerals are those which has some biological origin, For example, coal that you find today. How that coal was formed? So thousands or probably millions of years back, there were trees, there were vegetations that got buried under earth. And because of intense heat and pressure, what happens? Largely carbon content remained. And today we have this particular coal. So coal has a biological origin. Therefore, it is an organic mineral. Similarly, there can be inorganic minerals also. Inorganic minerals are those which don't have any biological origin. For example, iron ore. Iron ore is an inorganic mineral. Copper is an inorganic mineral. Fine. Then also we hear this particular word ore. What is an ore? In most simple words, ore is simply a special type of a rock or that kind of a rock from which any mineral or a specific mineral can be exploited in a commercial way. Let's understand this particular thing. Suppose this is a piece of rock. I spend 10 rupees. In mining iron ore from this. So at least iron ore that I'm extracting, its value should be 70-80 rupees. Then only it will make sense for me to mine this rock, to process this rock. However, if I'm spending 10 rupees and I'm getting only 5 rupees of iron ore, it doesn't make sense. So maybe in this particular rock, there are traces of iron ore, but I will not use it. I will not mine it. This is a rock and not an ore. So what is an ore? Ore is a special type of a rock in which mineral content is higher. So much higher that mining mineral from it makes a commercial sense, makes an economic sense. Understand this particular thing, guys, that when we talk about ore, all ores are a kind of a rock, but every rock is not an ore. Okay. Now here on screen, you can see that we have different geological and biological processes by which ores are formed. Let's understand them very carefully. First is igneous crystallization. Now it is a very simple thing. We know that lava, it cools in form of rock. Now this particular lava, naturally it contains a certain minerals. Which get concentrated in certain type of rocks which turn in ore and we can exploit it. We have example such as chromium, platinum. Now chromium, platinum, this kind of mineral, it is often formed by igneous crystallization. Now here we have written granite. Now see, granite is technically not a mineral. It is a type of a rock, but sometimes granite also contains rich concentrations of quartz, mica, which are mineral. Okay, so igneous crystallization, it is a concentration of mineral when lava cools down in rock. Then next is hydrothermalization. Now, what is hydrothermalization? So basically, hot or warm water, hot or warm water, it comes on the earth's surface, it peeps on earth's surface from the deeper reaches of earth, and it brings with itself certain dissolved minerals, and this particular minerals, it get concentrated along the rock fractures, along the faults, and from there these particular minerals, they can be mined. And copper, lead, zinc, mercury, silver, they get deposited in ore through hydrothermalization when mineral rich water from the deep reaches of earth, it just evaporates and behind it leaves these particular elements. Then metamorphism is a process by which we find that earth's rocks, they get transformed under high temperature and pressure, and largely marble, slate, asbestos, fine, these stones, then asbestos, graphite, talc is formed by that. Then sedimentary processes. So basically, guys, you see this particular thing that rivers, they are flowing. Now, when rivers are flowing on its course, it withers a lot of rocks. On its course, it withers a lot of rocks, and it carries these minerals, and they place these particular minerals somewhere downstream. And by that, placer deposits are formed. So basically, sand, gravel, sometimes even the placer deposits of gold, they are carried by rivers when they are going downstream. They deposit it, and we call them as a placer deposits. So these placer deposits are formed through sedimentary process. Then there are biological processes. So certain living organism, they produce minerals. For example, pearls by oysters. Then phosphorus by bird feces. Okay. Then through withering. So basically, guys, what happens is, now suppose this is a rock. This is a rock. Now, when water will fall on this particular rock, and if that water is acidic in nature, what will happen? That acidic water will partially dissolve certain minerals in this particular rock, and some specific type of minerals, they will stay back. So what will happen? Certain minerals are dissolved and washed, certain minerals have stayed back, and it by that, concentration of specific minerals will increase, and that rock will become a ore. And by this way, bauxite is formed. So water, what happens? It concentrates certain insoluble elements by dissolving the soluble ones. Okay, I hope it is clear. Now see, as we talk about classification of mineral, it can be done in multiple ways. For example, classification of mineral can be done as metallic and non-metallic, metallic and non-metallic, major and minor minerals, major and minor minerals. In fact, on major mineral classification, questions has also been asked on prelims examination. Then critical minerals, then atomic minerals. So there can be multiple ways in which minerals can be classified. First, we have the most important one, that is minerals. They are divided as metallic, non-metallic, and energy minerals. Now, in metallic, we have a two type of classifications, actually three type of classification. Ferrous means which contain iron, non-ferrous which does not contains iron, and this non-ferrous, it also sometimes it is further subcategorized as the precious metals. Now, in ferrous, we have iron, manganese, nickel. Non-ferrous, we have copper, lead, tin, bauxite. And in precious, gold, silver, etc. we have. Then non-metallic means they don't contain metallic content, and mica, salt, potash, limestone, sandstone. These are some examples of non-metallic. And in energy, petroleum, natural gas are there. Critical minerals, major, minor, etc. Just I'm going to discuss in some time. That also will be discussed. Don't worry. Now further moving on. First of all, let's talk about legislative framework around mining in India. So when we talk about mining, mining is mentioned in 7th schedule concurrent list. Now concurrent list is one where certain subjects are contained on which both union as well as states can make law. So mining is written in concurrent list, and principal law on mining has been framed by Parliament of India, that is Mine and Mineral Development and Regulation Act 1957. Now, this particular law recognizes that mining has to be developed because development of a nation depends on its mineral wealth, but at the same time, environment is to be protected. Okay. Now, initially, Mines and Mineral Development Act advocated government's bigger role in mining in India. Okay. However, this 1957 Act has been amended many number of times. So we need not to read this original act. Major amendments we are going to read, don't worry. Now, next change that came with respect to mining landscape in India was in 1972-73, and if you have watched Gangs of Wasepur movie, you already might be knowing. So what happened? Coal got nationalized in 1972 and 73, and actually Coal India became only miner of coal in India, and actually it became world's largest coal miner. And I tell you in advance that monopoly of Coal India will continue till 2020. Then after that, in 1993, there was this national mineral policy that was issued. So 1993 means a post LPG era. We were moving towards liberalization. We were developing positive attitude towards private sector. So this 1993 national mineral policy, it announced that private sector's participation needs to be increased. More FDI is to be brought in mining sector. Then, however, things did not got much change, and only in 1999 MMDR Act was amended, and it allowed prospecting licenses to look for favorable sites, and mining lease for private sector. Here it was allowed that any company registered in India can apply for prospecting license and mining license. And what happened? Gradually, many international companies, they came and starting mining operations in India. Then the next major change that came with respect to mining scenario was MMDR Amendment Act of 2015. Now, this MMDR Amendment Act 2015 was instrumental because it introduced two institutions. Number one is DMF, District Mineral Foundation, and number two is National Mineral Exploration Trust. National Mineral Exploration Trust. First of all, these district mineral foundations were established, and even in UPSC question on this, DMF has also been asked. So basically, areas where mining is going on, there are a lot of environmental challenges emerge. Their groundwater gets polluted, air gets polluted. Many tribal communities, their lands are taken and they are not properly rehabilitated. So in order to ensure the welfare of tribal communities, in order to bring development in tribal areas, these district mineral foundations were created. Okay. So basically, there will be a board of trustees. Now, this board of trustees, it will contain representatives from district administration, mining companies, and local communities, and it will ensure welfare of the mining region. Now, basically, what will be done? So, royalty that is being paid by the miners, certain part of that particular royalty will be kept aside to ensure development of these particular regions. And 60% of the fund, okay, focus here, 60% of the fund that they are receiving, where they are receiving fund, they are receiving fund from the royalty. They have to be kept aside for improving drinking water, environmental preservation, pollution, etc. The next change that came here in this capacity was the National Mineral Exploration Trust, NMET. Now see this particular thing. Let's say there are 100 blocks of minerals that have been there where mining is going on. But there might also be many other potential sites. There might also be many other blocks where minerals can be there. So we need to constantly look out for new sites where minerals might be there. So this National Mineral Exploration Trust, it will explore new blocks where minerals will be contained. Okay. Now this NMET, its one more objective is also there to impose a penalty for illegal mining. So rat hole mining is going on in northeast, and many number of times illegally coal is mined, iron ore is mined. So that is to be controlled. Now NMET, it has apex body which is chaired by Minister of Mines, and executive committee which is chaired by the Secretary of the Ministry of Mines. And 2% of royalty, 2% of royalty. So miners, whatever royalty they are paying to the government, 2% of that royalty will go to this National Mineral Exploration Trust so that it can search for new blocks. Moreover, under this National Mineral Exploration Trust, there is also one more concept, is that some other agency which has experience in reconnaissance, which can look for prospective mineral blocks, they can get funding. They can get funding from the NMET. Okay. Then guys, next change that came was in 2016, that is National Mineral Exploration Policy. National Mineral Exploration Policy. Now this National Mineral Exploration Policy, further it supported private sector's participation in mineral exploration. Okay. Also it provided this particular thing that we need to provide in public platform all the geoscientific data with respect to minerals in India. So what are the potential sites, what is the potential mineral reserves that are there, all that data needs to be provided on public platform. Now guys, in this particular capacity, there is one particular development also that has happened this particular year, and I would like to share that particular development also with you. See, recently this National Geoscience Data Repository portal was launched by Ministry of Mines. Now, what is this portal? This portal contains all the geoscience data, what minerals are there, where they are situated, what is the potential of mineral blocks. Okay, all the geoscientific data with respect to minerals will be uploaded, and it will be spearheaded by Geological Survey of India and Bhaskaracharya Institute of Space Application and Geoinformatics, and it has been created under National Mineral Exploration Policy 2016 that we have just discussed. Okay, so two institutions that are spearheading it, Geological Survey of India and Bhaskaracharya Institute of Space Application. Now, going back to our main discussion. Then in 2022, next major changes came. In 2022, next major changes came. So basically, guys, here what happened, coal mining was proposed that it should be given to the private sector players. Now see this particular thing, guys, that what happened in 2018 earlier, Cabinet Committee on Economic Affairs permitted that private firms should be allowed for the commercial coal mining. Now before that, keep one particular thing in mind, don't get confused. Earlier, private sector were given coal blocks, but they were given the coal blocks for captive mining. Captive mining. Now what is captive mining? Captive mining is means that you are mining coal and you will use it for your own consumption, for example, suppose there is a company, they have aluminium plant, or let's say they have iron ore plant, and they need a lot of electricity, or they need a lot of coal. So basically what they do, they will have their own coal mine, will exploit coal and will use for their own purpose, that is captive mine. But apart from captive mine, even for commercial angle, private sector should be allowed the entry in coal. And finally in 2020, under Atmanirbhar Bharat Abhiyan, government says that we are going to privatize, or we are going to allow private sector participation in coal. And actually what happened here, please understand very carefully. So in 2020, Mineral Law Amendment Bill was passed, and it opened the coal sector for commercial mining by private players. Then also one more thing that happened is that coal gasification and coal liquefaction is to be encouraged. We'll understand that also what it contains as when we'll discuss about the coal. And also rights were to be given for extraction of coal bedded methanes from the mines of Coal India. So coal bedded methane, it is a gas which is often built in the coal mines. So for extracting it also, the auctions will be made. These were the changes that came. Then guys, finally, there is one major change that has happened recently, that is MMDR Amendment Act 2023. MMDR Amendment Act 2023. Very important. It largely has brought three changes. Change number one, six six atomic mineral have been declassified. Which minerals have been declassified and what is its implication? Number one, first of all, beryl and beryllium, lithium, niobium, titanium, tantalum, zirconium. So basically, guys, there were 12 atomic minerals, and these 12 atomic minerals can only be mined, can only be exploited by government. Private sector is strictly not allowed for the atomic minerals. Now, out of this 12, these six minerals, they have been denotified. It means that now private sector can exploit these minerals, can mine them. Now if you see, lithium is one. Now you know that EV revolution depends on lithium ion batteries. So for exploitation of lithium, for exploitation of a titanium, zirconium, fine, private sector is now allowed. This is first change that has come. Second change that has come is that for critical minerals, only centralized auctions will be there. Only center government will do auctions for the critical minerals, but one catch is there. Money that will be generated, that particular money will go to state government. So let's say there is a state of Jharkhand, and in that Jharkhand there is some mine where there are, let's say there is some kind of a block where mineral is found. That block is given to XYZ corporate. Now the money in royalty that this XYZ corporate will give, it will go to the state government, fine, not the center government. Then next thing is that basically license for deep seated and critical minerals can be given. Now which type of license? Exploration license. That let's say there is some startup which has developed good techniques that through remote sensing with very preciseness they can identify potential sites, so they can explore. Exploration license can be given. Now these exploration license initially will be given for 5 years, then they can be extended for 2 more years. So these are three major changes that have happened in MMDR Act of 2023. Now further moving on. So guys, as we are talking about legislative framework, there is also one more policy. Why to leave that? Let's discuss that also, because UPSC examination, these things are going to help you a lot. So when we talk about oil and gas, for that we have a separate policy by the name of HELP, Hydrocarbon Exploration and Licensing Policy. Hydrocarbon Exploration and Licensing Policy. Now this particular policy was brought after replacing NELP, that is New Exploration Licensing Policy. Now HELP, only 4 features are the ones which are important for our examination that you should know. Number one, uniform license for all hydrocarbons. Now understand this thing, that sometimes there are certain blocks in which you will also find mineral oil, you will also find natural gas. So basically one combined license is to be given so that a person can mine both of them at the same time. It will make commercial sense. So uniform license will be given for all the types of different type of hydrocarbon. Fine. So suppose there is a coal, but in coal you can also mine the coal bedded methane. Then there is open acreage licensing policy. Now guys, understand this particular thing, that up till now what used to happen, government will offer that okay, these are the blocks that we are giving for auction. But now, rather than government giving you certain specific blocks, you can approach government and can ask for the block that you want. So basically explorers, they can themselves identify potential sites where there are mineral reserves, there is gas reserve, they can go to government and can ask for its auction. Then third is revenue sharing model. So in revenue sharing model, so rather than sharing some fixed amount of money, so revenue that a miner is making, revenue that a company is making by extracting a particular kind of a gas or something like that, they need to share it. Fine. So these are major changes that have come. Then when we talk about minerals, so minerals are also classified apart from metallic, non-metallic, ferrous, non-ferrous as major and minor, and here questions have also been asked. So please listen it very carefully. Now first of all, understand one very basic things. When we talk about minor mineral, with respect to minor mineral, power and control of minor mineral is in the hand of state government. But when we talk about major mineral, mining, power and control with respect to major mineral is in the hand of union government. Now understand this thing, minor minerals will be notified by center. Minor mineral will be notified by center, but after that legislation control of minor mineral will be with the state. So according to MMDR Act, minor minerals, fine, it can be notified by center, but power to frame laws, power to regulate it will be with the state government. And some examples of minor mineral is building stones, clay, gravel, ordinary sand. Understand this thing, that we are not talking about the specialty sand. For example, silica sand, it is not a minor mineral, it is a major mineral. In minor mineral we have ordinary sand, ordinary clay that we have. Now here I have given you an entire list. I have given you an entire list. For example, major minerals, metallic major minerals, non-metallic major minerals, fuel minerals, and minor minerals. You can just take down this particular notes and you can go through this particular list. Also, one more thing, that when we talk about the major minerals, so major minerals are written in the first schedule of MMDR Act 1957. Okay, so we have this particular kind of a classification. Now, let's talk about mineral belt in India. Now, see, certain points that you should note down before going in this particular thing. See, first of all, there is uneven distribution of minerals in India. Fine. There are certain belts where largely minerals are deposited. Secondly, northern plains, largely there will be poor minerals. You don't find mineral. Why? Because there is a thick alluvial soil. So accessing mineral is not there. Fine. This alluvial soil, it does not has homogeneous structure. Therefore, ores will not be found here. Then Himalaya, in Himalaya, there is some mining that goes, but Himalayas, a lot of mining does not happens here. Number one, because of complex geology. Okay, it is basically homogeneous rocks are not found in that much number. Then transportation is very difficult. Then environmental factors, and then the small quantity of reserves. So a lot of mining doesn't goes in Himalayas. Though recently what happened in Reasi region of Jammu and Kashmir, lithium reserves, they have been found. They have been found. Now, majority of minerals that we have in India, they will be found in old crystalline rocks of peninsular India. Peninsular India. Now see, here we have this particular map, and largely we have five mineral belts in India. Five mineral belts where majority of mineral or more than 95% of mineral is contained. Now, the first one we have here, one by one we'll see. First one, this particular region, this particular region. Now, this region, fine, it comprises largely Chota Nagpur and Odisha Plateau. It contains Jharkhand, West Bengal and Odisha. Now, this particular belt is called as Northeastern Peninsular Belt. Northeastern Peninsular Belt, Jharkhand, West Bengal and Odisha. Now, this particular belt has a lot of iron ore, coal, kyanite, specifically known for coal and iron ore. Then, after that, second one, this particular region. Okay. Now, this particular region, it is a central belt. Why? Center of the country, central belt. Now, this central belt, it has Chhattisgarh, Madhya Pradesh, Maharashtra, Telangana, Andhra Pradesh, and resources that we have here in this central belt. Resources that we have in this central belt are manganese, bauxite, marble, gems, limestone, mica. Okay. Then after that, guys, here, after that, here, fine. After that, here we have this particular area. Now it contains the areas of Aravali. Now this is Aravali range here, and Rajasthan and Gujarat are largely included here. Rajasthan and Gujarat are largely included here. This is called as northwestern belt. Northwestern belt, and largely here non-ferrous minerals, copper, lead, zinc, uranium, and even stones such as marble will be found here. And they are actually recent formations compared to formations of central India and northeastern peninsular belt. Compared to these two belts, this belt, that is the northwestern belt, is a recent formation. Okay. Then after that we have southwestern belt. Now southwestern belt, it contains Goa and Karnataka. It contains Goa and Karnataka. And iron ore, clay and bauxite are major mineral. In fact, magnetite iron ore will be found here in large numbers in Karnataka. Then this particular belt is a southern belt, and it largely consists of Karnataka and Tamil Nadu. And Tamil Nadu specifically, there is lignite coal which will be found in Neyveli region. Neyveli region. Then after that, guys, in northeast we have certain reserves. We have certain oil reserves. Specifically, Assam, we have oil reserves that we have here. So basically, guys, here there are different symbols that are given. For example, this black dot is for iron ore, then C is for coal. Now this particular hump kind of a structure is for manganese, then triangle is for copper. So basically, if we talk about the northeastern peninsular belt, first of all, what minerals we find here? We find here that there is iron ore, there is coal, then we also find here manganese, okay, then we also find here some copper. We don't have that much copper here. A lot of copper we'll find here in this particular region. We'll find copper here in this particular region. That is in Rajasthan and Madhya Pradesh, if you focus here. Fine. Don't worry, all these particular things will get cleared. So largely, how many mineral belt we have in India? How many mineral belt we have in India? Let's revise it in just 30 seconds. So number one is northeastern peninsular belt. Okay, first one is northeastern peninsular belt. Then we have central belt. Then we have here southern belt. Here we have southwestern belt, and here we have northwestern belt. Northwestern belt. Okay, so one, 2, 3, 4, 5. These are the 5 mineral belts that we have. Now, moving on. First of all, we are going to discuss about iron ore. First of all, we are going to discuss about iron ore. Now, first of all, iron ore is very important for the economic well-being, and in fact, the usage and consumption of iron ore and steel directly is linked with economic well-being of a nation. Now, when we talk about iron ore, largely we have 4 types of iron ore: magnetite, hematite, limonite, and siderite. Now, this classification is on the basis of iron ore content that is there. Iron ore content that is there. So, magnetite has 72% plus iron ore content. Hematite has 60 to 70%, limonite 50 to 60, and siderite 40 to 50, sometimes even less than that. So largely magnetite and hematite are the 2 iron ores by which commercial exploitation with for the iron ore makes sense. Now, magnetite, we have large resources in Jharkhand, Andhra Pradesh, Tamil Nadu, Goa, Karnataka. In fact, Karnataka is one which has majority of magnetite in India. And for hematite, we have the states of Jharkhand, Andhra, Odisha. Now, let's talk about the locational aspects with respect to the iron ore, where iron ore is found. Now, before going here, let me show you on the map. So, basically, there are 4 belts in which largely iron ore is located. These 4 belts are there. Now, this particular belt is Jharkhand Odisha belt. Jharkhand Odisha belt. This belt is largely consisting Chhattisgarh and Maharashtra. Then this particular belt is largely consisting Karnataka, and this particular belt is again consisting Maharashtra and Goa. So these 4 belts again: Odisha, Jharkhand, Chhattisgarh, Maharashtra, Karnataka, Maharashtra, Goa. These 4 belts are there. Now these belts are often known either by the ranges or by the major mines that we have. For example, Odisha Jharkhand belt. So here in this particular belt, number one, we have largely hematite reserves. Hematite reserves. Now here Barabil Koira Valley is there, which is the most famous location of iron ore here. And notable mines, the most important ones are Badam Pahad of Odisha, Goa mine, and Noa Mundi mine of Jharkhand. So Badam Pahad Odisha, Goa, and Noa Mundi of Jharkhand. Apologies if I pronounce some name wrong. This is the one. Now if we again go back to the map here, so here you can see that we have Goa. We have Goa. Then some other important locations are Kendujhar and Mayurbhanj also that we have here. Then next, after Odisha, Jharkhand will come little bit towards the western side, or towards the central part of India. And here we have Durg Bastar Chandrapur belt. Durg Bastar Chandrapur belt. Okay, so this particular is the Durg Bastar Chandrapur belt. Now here, guys, you can see that Durg is there. Then here Chandrapur is there. Now here we find this particular thing, that the most notable mines that we have is Balladella range, and Balladella mine is actually one of the largest mechanized mine of Asia. Also, it is in Chhattisgarh. So here you can see Balladella is there. So Balladella, Durg, fine, Bhandara, Chandrapur, they are the important ones. Fine. Then after that, third one, Odisha, Jharkhand, Durg, Bastar. Then third one that we have is Bellary, Chitradurg, Chukmangalur, Tumkuru belt. These are all important mines that we have here. and it is largely located in Karnataka, and Karnataka actually has largest magnetite iron ore resources in India. So here you see that Bellary is there in north. Then after that we have Chitradurga. Then if we go little bit towards the south, there is a Kudremukh. There is Kudremukh. Then there is a Tumkuru, Chikmagaluru. So if you go the same names, you'll find here Bellary, Chitradurg, Chikmagalur, Tumkuru belt. So this belt is in Karnataka, and largely which type of iron ore is found here is magnetite. And then finally Maharashtra, Goa. Now there we don't find very refined or very good quality of iron ore. Okay. Now here Goa and parts of Maharashtra, largely Ratnagiri district contains iron ore. Iron ore. Now some important statistics with respect to iron ore presence in India. Now guys, here this particular data that I have taken it from Indian Bureau of Mines. Now first of all, I told you that this particular region, Odisha Jharkhand belt, it has hematite reserves. So basically 79% of hematite in India is found in eastern sector. Fine, this particular region. Fine, Assam, Bihar, Chhattisgarh, Jharkhand, largely the Jharkhand and Odisha. 93% of magnetite is in the southern sector, and in that Karnataka is one which alone contributes 72% of magnetite. Okay, so this is actually first of all the areas which have the large iron ore reserves. Now, when we talk about the actual production, so actual production is by Odisha. So Odisha is doing the highest production of more than 51%. Then after Odisha, the next we have is Chhattisgarh. Then third that we have is Karnataka. So Karnataka, though magnetite deposits are highest, but in term of production, it is on third rank. Fine. So this is about it. Fine. I hope that you have understood it. And now moving to next one within the iron ore, that is iron ore processing. Iron ore processing. Now, when we talk about iron ore processing, so it usually happens in 6 steps. Number one, you simply mine iron ore from a mine. After that, that particular extracted ore, it is crushed and grinded in a kind of a powder. Then concentration is increased. Now see this particular thing, that if the concentration of iron ore is high, let's say that if it is a magnetite kind of an iron ore or high grade hematite, then directly you can use, otherwise it has to be concentrated. So basically how concentration is done? So concentration is done through the process called as beneficiation or benefaction. Now in this beneficiation, there are many different ways that are used, that is magnetic separation, flotation, gravity separation. So process of enhancing this iron ore content, let's say from 60% to 80%, 90%, it is called as beneficiation. So these kind of keywords also are asked in the examination, so need to keep in mind. Then after that, pelletization. Now what is pelletization? Pelletization are like that these iron, basically this iron ore will be just be converted in these particular small kind of pebbles. Okay, in this pelletization there is a binding agent that is used, which converts them in these kind of pebbles or in these kind of small balls, and this binding agent is called as bentonite. So beneficiation is process of increasing iron ore content. Bentonite is the binding agent by which this iron ore is converted in these balls or pebbles kind of things. Then finally there is a smelting. Then there is a smelting that is done in a blast furnace. Now in this smelting, what happens? So basically in smelting there will be a blast furnace which will be heated, and in here number one, iron ore will be added. Then coke will also be used. So coke, what it is? It is high carbon rich material which is actually derived from the coal. So by refining coal we get coke. Now this coke is used as a reducing agent as well as a fuel. Then after iron ore and coke, which will work as a fuel and reducing agent, limestone is used. Now why limestone is used? Limestone binds with impurities and creates slag. So slag is a kind of a waste material. So limestone basically gets attached with the impurities and consolidate these impurities in the form of a slag, and this particular slag can then be removed. Okay, so iron ore, coke and limestone. Now guys, when we have a blast furnace, in furnace, so continuously fuel, coke, iron ore has to be supplied. Now basically I told you that here we used coke. Basically, when we talk about coke, so coke is created through the process of destructive distillation. So through this destructive distillation, coal is converted in coke, and coke has very high carbon content and very few impurities, impurities. Also guys, one more thing, I'm going to discuss about coke and coal in little bit more detail when I will discuss coal. So there, through with the help of a table, I'm going to discuss that what is difference between coke and coal. So don't worry on that also. Now, there are certain impurities also which are found with the iron ore. Now let's talk about these major impurities and what will be the consequences of these impurities if they are left in iron ore. First, we have sulfur. Now, if sulfur's content is high in iron ore, this sulfur, it forms iron sulfide, which makes iron brittle, and because of that, strength gets impacted. Then next we have phosphorus. Phosphorus combines with iron and forms a phosphide. Now, what this phosphide does? Phosphide makes iron exceptionally hard. But if iron becomes too much of hard, its ductility gets impacted. You cannot give different shape to that. Then tin. Now what happened? Tin forms a kind of a film. It forms a kind of a film, and by that particular film, again, what happens? The iron becomes basically it becomes brittle, and oxygen carries oxidation. Oxygen carried oxidation and makes iron weak. Now, we'll be reading about manganese also. Basically, guys, when steel is made, fine, with steel, manganese is added. Why manganese is added? Because manganese is a deoxidant. So, oxidation that has been done by the oxygen, that deoxidation is done by manganese. So, these are major impurities, and how these major impurities impact iron ore that we have seen in prelims. There might be a question on this particular line. So, I hope you've understood it. Now, see, once iron ore is processed, so first thing that you will get is pig oil, is pig iron. Now, when we talk about pig iron is very raw and it has a high carbon content in the range of 3.5 to 4.5%. This pig iron is further this pig iron is further purified, and this carbon content will be reduced in blast furnace. So again, this pig iron will be smelted, and coke and limestone will be added. Coke and limestone will be added. Now, they basically, this pig iron, it is brittle. It has a certain kind of usages. It has certain limited kind of usages, and it is largely used as a raw material for making cast iron that we are going to see here. Okay. Now, what is cast iron? So basically, cast iron is one where pig iron has been purified and this carbon content of 3.5 4.5% is reduced. So in cast iron, carbon content ranges 2 to 4%, and it is made by remelting by processing pig iron that we have already formed. Now, this particular cast iron, it has good compressive strength, it is hard, brittle, fine, and it is used for making pipes, automotive parts in vehicles, cookware, machine tools. Then further, cast iron is processed, and this carbon content is further reduced. It is further reduced between 0.2 to 2%. Fine, here 2 to 4%, here 0.2%. Now, basically, carbon content will be reduced and certain additives will also be added, such as manganese, which acts as a deoxidant. Chromium will be added, nickel will be added, vanadium will be added. And then we get one of the most versatile metal, that is steel, which is strong, ductile, can be treated with heat, okay, can bear a lot of pressure, but at the same time, it maintains flexibility. Then wrought iron. Now, wrought iron has even lower carbon content, which is less than 0.08%. 0.08%. So, repeated heating, repeated purifying of pig iron reduces this carbon content successively, and very low carbon content we get wrought iron. Now, this wrought iron is exceptionally malleable, ductile, tough, and a lot of shapes, and easily shapes can be given. And it has been used for decorative iron work, railings, for making agricultural tools. Okay, so this is, and you should know basic difference: pig iron, carbon content very high, cast iron 2 to 4%, then steel, and then wrought iron. So this is about it. Then moving on, we have now manganese. Now, guys, when we talk about manganese, manganese is not found free in nature. Manganese is not found free in nature. It is combined with iron, laterite, or some other kind of a mineral. Okay, and ore which is most economical for extracting manganese, it is pyrolusite. So pyrolusite is most important ore of manganese. Now, when we talk about the manganese ore in India, so basically, guys, first of all, India is ranking fifth in terms of the production of manganese. Now, see, when we talk about manganese reserves, so in terms of reserves, India is on second rank, but in terms of production, India is on fifth rank. India is on fifth rank. So highest reserve of manganese is in Zimbabwe, and after that, second highest reserves are in manganese. And production, first is China, second is Gabon, third is South Africa, fourth is Australia, and fifth rank we have India. Now, in India, majority of manganese is actually produced by the three states, that is Madhya Pradesh, which is producing 33% of manganese, then Maharashtra and Odisha. So, Madhya Pradesh, Maharashtra, Odisha. But when we talk about reserves, then the ranking is different. So, in terms of reserves, highest reserves are in Odisha, 44%. After that, 22% Karnataka, and then Madhya Pradesh is on third rank. But in terms of production, Madhya Pradesh is on first rank. Okay, Madhya Pradesh is on first rank. And when we talk about manganese, okay, so this particular data has been taken from Indian Bureau of Mines. Indian Bureau of Mines. Okay, now manganese, its importance is obviously in iron and steel industry, and I told you that it is a deoxidant, and because of that, it is used in steel also. And if we talk about 1 ton of steel that is manufactured, 6 kg of manganese is to be mixed. So every 1 ton of steel, you need 6 kg of manganese. Then manganese is also used as a, it is also used as a bleaching powder. It is used as insecticides, paints, batteries is also used. So these are important usages of manganese. Please, guys, keep it in your mind, because many number of times usages are also asked. So what are usages? Biggest use, it is used to further process iron ore and steel. Okay, it is a deoxidant, bleaching, insecticide, paint, batteries. Now, guys, when we talk about coal, quality of coal depends on the content of carbon. So, carbon needs to be more and more, moisture and other impurities need to be less and less. Now, we see this particular thing that millions of years back, basically organic vegetation, it got buried under earth. And what has happened, because of heat and pressure, mostly oxygen, nitrogen, moisture, it has depleted, and the carbon proportion has stayed. More carbon, better a coal is. Now, on basis of carbon, we largely have four types of coal: peat, lignite, bituminous, and anthracite. Now, peat is one where carbon content is less than 40%, 40 to 50%, less than 40%. And moisture content will be high. Now, because of this high moisture content and low carbon content, it will burn just like wood. It will burn just like wood, and it will produce more smoke and ash. Then we have lignite. Now, lignite, here carbon content is between 40 to 55%, and it will also have high moisture, high impurities. And also because of its high moisture, high impurities, it is also called as brown coal. Brown coal. So, peat is inferior, lignite is intermediate variety of coal. Intermediate variety of coal. Then third is bituminous coal. Now, bituminous coal, it is called as soft coal. It is called as a soft coal. It has high calorific value, and because of its high calorific value, and because of relative affordability, there is a lot of usage of bituminous coal that is done. And here carbon content will be 40 to 80%, and moisture content will be moderate. And most superior quality of coal that we have is anthracite coal. And anthracite coal carbon content is 90 to 95%. It will burn slowly, and it will produce very less smoke. Now, why smoke will not be there? Because volatile compounds and moisture's content has been reduced too much. So therefore anthracite coal will be the most superior one. Now, guys, before moving in the state wise location, let's take first of all overview of major coal fields that we have. Now, basically, when we talk about the coal fields, coal bearing coal fields, now these are the major coal fields that we have. Now, first of all, guys, the major producer of coal in India is number one, Jharkhand. After Jharkhand, number 2 producer that we have is Chhattisgarh. Then number 3 producer that we have is Odisha. So very clearly we find this particular thing, that this particular belt towards the eastern part of India is the largest coal bearing belt. So number 1 producer is Jharkhand, number 2 producer is Chhattisgarh, number 3 producer is Odisha, and number 4th producer is Madhya Pradesh. Madhya Pradesh. So this particular area is largest coal bearing area. Then after that we have some inferior quality of coal in Tamil Nadu also. Then towards this particular belt of Assam, Meghalaya also we have coal. Now particularly this particular part of Meghalaya, here rat hole mining is done. We are going to discuss that also. So this was just to give you a kind of a snapshot about the coal mining. So Jharkhand, Chhattisgarh, Odisha, Madhya Pradesh, 4 largest producer. In Jharkhand, largest major coal fields that we have is Dharia coal field, Dhanbad coal field, then Bokaro coal field, Hazaribagh, Girdi, Karanpura. The most important one is Jharia, Dhanbad and Bokaro. Remember these names at least, if more you have a problem to remember. Then after that Chhattisgarh. Now see, when we talk about reserves wise Chhattisgarh is third. But in terms of production, Chhattisgarh is second. Okay. Odisha, reserve wise it is second, but in terms of production it is third. So I hope you got the connection. Now Chhattisgarh major coal fields are Korba, Korba, Hasdo, Chirmiri, Jhilmili. Okay, Jhilmili. Okay, again Korba, Hasdorand, Chirmiri, Jhilmili. Then in Odisha, major coal fields are Talcher coalfield, Rampur Himgir coalfield, and the river valley of Ib River, and Sambalpur. Sambalpur is the one where a lot of coal is contained. And then in Madhya Pradesh, Singrauli, Penchkana, Tawa. These are important coal fields that we have. Okay, and I have shown you all this particular thing here also. Now, guys, if you remember, when we were discussing about iron ore, we discussed briefly about coking coal and non-coking coal. So basically, coking coal is one which is used as a raw material in steel production. It is also used in iron ore processing. Now, when we talk about coking coal, so coking coal is metallurgical coal and it contains very low sulfur, due to which impurities are kept under control. It contains very less moisture and it has very much less ash. But when we talk about regular coal, which is called as thermal coal, this regular coal can also be referred to as non-coking coal. It has high sulfur content, also ash content will be good. Now, coking coal will be used for metallurgical purpose, that is to make steel. But basically, thermal coal, it is just used for its calorific value, just for heating purposes and in generation of power. Fine. It basically, this thermal coal or regular coal will be used. Fine. Now, basically, when we talk about production of coke, so how coke is produced? So it is produced by heating the bituminous coal without air. So if you remember, guys, bituminous coal, it is the second best coal. So when bituminous coal is heated without air, we can get a refined product, that is coke. And major producer of coke are Australia, Canada, US. In India, we have very less coke. So therefore, we have a lot of dependence. We have a lot of dependence on these particular countries for coke. Even we have discussed this particular thing, I guess, earlier also. Now, in the context of coal, I discussed with you rat hole mining, because when I was telling you here that this belt coke is produced, so Meghalaya rat hole mining is done. So what is rat hole mining? Rat hole mining basically involves digging up narrow holes in which many number of times children will go and they will collect the coal. So it is very much primitive and hazardous method. And even this rat hole mining was in news because, guys, in Uttarakhand, when tunnel collapse happened, Silkyara tunnel collapse happened, rat hole miners were called. Now, rat hole mining involves two type of methods, that is side cutting and box cutting. So in side cutting, suppose this is a hill. So basically sides of the hill will be cut, and in box cutting what will be happening, a cutty kind of a, in box cutting what will happen, suppose this is ground. So a vertical tunnel will be formed until they reach the coal seam. The coal will be connected, and largely children do that. So therefore, rat hole mining has also become a concern. Now, let's talk a little bit about the coal consumption in India. So majority of coal that we have in India, it is used for electricity generation. 70% of coal is being used for electricity generation. Though we are moving now towards the renewable energy, and already in revised INDC goal that we have taken a target that 50% of installed electricity capacity by 2030 will come from renewable. But still, large dependence on coal is there for the energy generation. Now, we also have a high import dependence, 20 to 25, specifically of coking coal, because you know this thing that this type of a coal is not found in India that much. Then moving on, there is one more concept that I would like to discuss with you, that is coal gasification and coal liquefaction. Now, first of all, what is coal gasification? Coal gasification is to convert coal, which is solid, in gas. Now, how coal gasification is done? So basically, in coal gasification, you will take coal, and this coal is heated in the presence of oxygen and steam. In the presence of oxygen and steam, and through this particular process, synthetic gas or syn gas is produced. Now, this particular syn gas or synthetic gas, it is mixture of carbon monoxide, hydrogen, carbon dioxide, and methane. And from here, hydrogen can be extracted, methane can be extracted. Okay, for their for because methane can be used as a can be used as a gas to power the vehicles for cooking. Similarly, hydrogen can be used. In fact, we are also running the National Green Hydrogen Mission. Though in National Green Hydrogen Mission, hydrogen that is made, it is made through the electrolysis of water. But anyhow, hydrogen is an important source of energy that can be exploited here. Okay, so basically, what will be done in coal gasification? So coal will be heated in a gasifier in presence of oxygen and in presence of steam. If you heat coal under pressure, then what will happen? A mixture of gas containing carbon monoxide, hydrogen, carbon dioxide, and methane will be produced. Okay, and this synth gas has a lot of application, as I told you. Then coal liquefaction. Now, what is coal liquefaction? Coal liquefaction is process of converting solid coal in liquid. So basically, guys, how it will happen? So basically, the same process. First, coal will be heated under pressure and with the steam in gasifier. So first, what will be done? So coal will be converted in synthetic gas that we have already discussed. And when it has been converted in synthetic gas, then it will be converted in the liquid hydrocarbon with the Fischer Tropsch synthesis. Fischer Tropsch synthesis. Okay, and this liquefied coal can be used for producing synthetic diesel, gasoline, etc. Okay, so this is about the coal liquefaction and coal gasification. Coal liquefaction and coal gasification. Now, this coal gasification and liquefaction, what it can do? It can enhance India's energy security and India's dependence on other countries can be reduced. India's dependence on other countries can be reduced. So this is, guys, all major things about the coal. And now moving on to the next one. The next is chromite. Chromite. So basically, chromite is the most economical ore of chromium. It is the most economical ore of chromium. And chromium, why it is important? Chromium is used for plating. Okay, plating. So there is a shiny plating often on metals that is done, by which metal becomes a shiny, silvery in color. So for chromium, for chrome plating, chromium is used. Fine. Chromium is also used for producing corrosion resistant alloys, super corrosion resistant alloys. Okay, and also it is used in making of stainless steel. It is used in making of stainless steel. Now, when we talk about the chromite in India, so majority of chromite reserves in India, around 93% of chromite reserve in India, it is located only in the state of Odisha. Okay, then there are some minor, 7% chromite will be found in the other parts of country. There we have Manipur, Nagaland, Karnataka, Jharkhand, Maharashtra. And who is the major producer? So reserves are also in Odisha, and major producer is also Odisha. In fact, Odisha produces 99% of India's chromite. So major producer is also Odisha, major reserves are also in Odisha. Then after that, Odisha second major producer is Karnataka. Karnataka. Okay, so this is about the chromite. Then after chromite, bauxite. Now, bauxite is chief ore to make aluminium. To make aluminium. Okay, and guys, there is one story. During the time of Napoleon, aluminium was considered as so rare and so precious that Napoleon himself used to eat in aluminium plates and used to give food to his guest in the gold plate, silver plate. Okay, so aluminium was that expensive and was considered so important at that point of a time. Now, guys, as we talk about the production of bauxite, so highest production of bauxite in India is done by Odisha, 95%. And after Odisha, Gujarat is second producer and Jharkhand. Jharkhand is at number 3 in terms of the production of bauxite. Now, when we talk about the major bauxite mines, so we have these particular mines here. That is, we have the Sambalpur in Odisha, Balangir, Kalahandi, and Koraput. Okay, so Sambalpur, Balangir, Kalahandi, Koraput. These are the most important mines that we have in Odisha. Then in Jharkhand, Lohardarga, Ranchi, and Gumla. These are the most important mines. Again, guys, my apologies if I pronounce some name wrong. Intention was not that. So these are the important mines and important locations with respect to bauxite. Now in Gujarat also lot of bauxite is mined, but in coastal areas we don't have that much bauxite. Apart from coastal areas, Gujarat has the bauxite reserves. Then moving on, next is copper. Now, copper happens to be one important mineral in terms of electric industry that is concerned. Now, copper was in news because, guys, when we talk about Sterlite copper plant in Tamil Nadu, it got closed few years back because of the protests that were happening. Now, Sterlite happens to be one very important copper smelter in India. But it got shut down because of the protest by the people. Now, when we talk about copper, so copper are found in rock veins. And India, biggest challenge is that we have a very low copper or low grade copper ore we have. Now, this copper, it contains just 1% of metal content, which is very much less than the global average of 2.5%. Now, when we talk about copper in India, so majority of copper is found in Madhya Pradesh, and in fact, Madhya Pradesh right now happens to be the largest producer of copper. Then Jharkhand is the second largest producing state of copper, and then we have Rajasthan. Okay, and important mines of copper if we talk about, so Betul and Balaghat happens to be two important, most important copper mines in Madhya Pradesh. Then in Jharkhand, Singhbhum. Okay, then in Jharkhand, Singhbhum, Hazaribagh, Palamu. It happens to be important. Then in Rajasthan. Okay, so Bhilwara, Jaipur, Jhunjhunu, Pali, Sirohi. These are important places where the copper mines will be found. Now, most important application of copper is in electrics because it has exceptionally good electricity conductivity. So therefore, in wires, therefore in automobiles, therefore in electronics, it is used. Now, basically, guys, when we talk about copper, if we mix some other elements, so copper assumes a different composition. For example, when copper is mixed with zinc, it becomes brass. And there is a lot of application of brass in handicraft items, in decorative items. And when we mix copper with tin, it transforms in bronze. Okay, so copper plus zinc becomes brass. Copper plus tin becomes bronze. Okay, moving on. Then mica. Now, mica is a non-metallic mineral. And mica is used for its insulating properties. Okay, it can withstand high voltage shocks. And in the context of mica, India actually dominates mica production, and 60% of total output of mica is produced by India. Now, major producers of mica in India. Number one, we have Andhra Pradesh, and Andhra Pradesh is actually producing 93% of mica. Then after Andhra Pradesh, next we have Rajasthan. which is second largest producer of mica, and after Rajasthan, Jharkhand is there. So Andhra Pradesh, second Rajasthan, and third Jharkhand. These are major producers of mica. Then next we have limestone. Limestone. Now see, limestone is used in a lot of industries. For example, limestone is used in cement manufacturing. It is used in manufacturing of steel, manufacturing of paints, paper, etc. However, the biggest use of limestone is in cement industry, and 75% of limestone in fact is actually used in cement. 16% limestone is actually used in iron and steel. Now, in terms of production of limestone in India, so Madhya Pradesh, Rajasthan, Andhra Pradesh, Gujarat, Chhattisgarh, these are the major producers of limestone. And the largest among these are is the Madhya Pradesh. So Madhya Pradesh is largest producer of limestone. After Madhya Pradesh, so first is Madhya Pradesh. After Madhya Pradesh, next major producer of limestone is Rajasthan, MP, Rajasthan, and after Rajasthan, Andhra Pradesh is the third producer of limestone. Fine. So that is about limestone. Then next we have a graphite. Graphite. Now, when we talk about graphite, guys, so graphite holds a lot of applications. Number one, first thing that you should know is that graphite is the purest form of carbon. It is purest form of carbon. Okay, and even graphite has higher carbon content compared with anthracite. So if you remember, we have discussed anthracite has carbon purity of up to 90%. So even more than anthracite, carbon content is contained in graphite. It is contained in graphite. And graphite has a lot of industrial application, It is highly resistant. It is highly resistant to heat. Chemically it is unreactive. Okay, now when we talk about India's major graphite, so basically now Arunachal Pradesh holds 43% of graphite reserves. Jammu Kashmir has 37% of graphite reserves. Then Jharkhand has 6%. Tamil Nadu has 5%. Okay. Now, as we are talking about graphite, one more very important aspect of graphite is that graphite is actually non-metal non-metal and only non-metal which can conduct electricity. So it is a conductor of electricity, being a non-metal. Now this is very important aspect with respect to prelims examination, and majority of graphite reserves will be found at convergent plate boundaries. Why? Because here rich shale and limestone, they undergo metamorphism, and it leads to the graphite. So this is about it. Then the next we have is diamonds. Now guys, when we talk about diamond, so basically we actually don't have too much of the diamond resources in India, Largest producers of diamond is Russia, Botswana, Canada, Australia. Okay, and in fact Russia has they have the largest and richest diamond resources in diamond polishing and in diamond processing. Surat, Gujarat processes the maximum diamonds, but in terms of production we don't have that much of diamond production. And right now, in terms of production, if we talk about, so diamonds are right now being produced in Panna in Madhya Pradesh only. Panna in Madhya Pradesh, diamonds are being produced. Okay, so that is about it. Now guys, further moving on to the energy minerals. Now when we talk about energy mineral, so first of all guys, as we talk about energy mix of India, even right now, the majority of electricity that we derive from coal. Though according to Ministry of New and Renewable Energy, 41% of India's installed electricity is coming from renewable, but still coal plays a major role. Now, when we talk about the energy, we have energy sources as conventional and non-conventional. So conventional, they include traditional such as coal, oil, natural gas, and non-conventional, they include solar, wind, geothermal, etc. Now coal already we have discussed, and now the next one that we are going to discuss will be petroleum. Now guys, see this particular thing, that first of all, when we talk about petroleum, uh, basically 84% of India's oil needs, they are met by imports. We don't have too much of reserves for oil as well as gas also. You already might be knowing. Now, crude oil, it actually occurs in sedimentary rocks, and a lot of the maximum crude oil, it was formed during tertiary period. Now, petroleum also happens to be an organic mineral. And in India, if we talk about the oil petroleum production, so we can divide the petroleum production facilities in two parts, that is the onshore as well as offshore oil fields. Onshore and offshore. Onshore means land based, offshore means off the land in water. For example, Bombay High, it is not on land, it is in water. So onshore oil fields, basically we have largely three. We have largely three here. Number one is Brahmaputra Valley, then we have Rajasthan oil field, and then we have Gujarat oil field. Now in Brahmaputra Valley, that is in northeast, there is the Digboi oil field in Assam, and in fact it is oldest in India. It is oldest in India. It was started during Britishers. So Digboi oil field, Assam, oldest, started during the British period. Then Nahar Katia field and Moran Hugrijan field are the other one which are there in northeast. Then in Rajasthan, there is a Baner district of Rajasthan where there is a discovery that has been done. There is a discovery that has been done. Then also, find there is the Mangla oil field, Rajeshwari oil field, and Saraswati oil field. They have also been identified in Rajasthan. So, Digboi in Assam, Naharkatia, Moran, Hugrijan, then Baner, Mangla, Saraswati, okay, and Rajeshwari. Then in Gujarat, Ankleshwar, Kambat, Lunej, Ahmedabad. Here, there are the oil field that have been discovered. So these are largely the land-based oil fields. And then when we talk about the offshore, means off the land, then on west coast and east coast, we have oil fields. So on west coast, we have iconic Bombay High or Mumbai High. Mumbai High, fine. Then we have Sagar Samrat, Alia Bet. Alia Bet is in Gulf of Kambat. Now see, in eastern coast, three river basins are the ones which have the most potential of oil. That is Godavari, Krishna and Kaveri. Okay, Godavari, Krishna and Kaveri. Now Rava field is in Krishna Godavari basin, and Narimanam and Kovikalappal oil field is in Kaveri. So Rava in Krishna Godavari and Narimanam and Kovikalappal in Kaveri. These are two offshore oil fields on eastern coast. On west coast, iconic Mumbai High and Alia Bet are the two ones. Okay, so please keep in mind. Now, though in terms of production, India does not hold a good rank, but in refinery we have huge capabilities. And actually, Jamnagar refinery in Gujarat, it is one of the world's largest oil refinery. And in fact, I told you that Digboi, Assam, they here refinery started during the British period time. So basically, in 1901, Digboi, Assam oil refinery was started here, which was one of the which was India's first oil refinery, and it was one of the earliest oil refineries in Asia. I'm not saying the first, but earliest one. Now, guys, as we talk about the global production of oil, we find this particular thing that Middle East, it has 50% proven resources, but its production is around 30%, less than 30%. US, it has just 2% of resources, but its production is around 10%. Then other major producers that we have is Canada, Latin America, Africa. Now guys, as we talk about the oil production, there is a cartel kind of an organization. You might have heard about the OPEC, which controls the major oil production. So basically, when we talk about OPEC, OPEC stands for Organization of Petroleum Exporting Countries. And these OPEC countries, basically, they control majority of oil production, 79.5% oil production. Non-OPEC countries, they just do 20.5% of oil production. These are the OPEC countries. Now guys, basically, please download this particular PDF notes, and country-wise distribution, country-wise production here you can see. Now, because in India, we don't have a lot of oil production, but our dependence, our usage of oil is pretty high. So we are going forward for the strategic petroleum reserves in India. Now, what will be the strategic petroleum reserves? So basically, guys, we are going to develop underground facilities We are going to design dedicated facilities in which the oil will be stored, so that if any oil crisis comes, if any slump, if any kind of a supply crisis comes in the oil, we can manage that particular crisis with the help of this strategic petroleum reserves. Now guys, already India has in phase 1 decided that we will develop 3 strategic petroleum reserves facilities to store oil, and they would be located in Vishakhapatnam, Mangaluru and Padur. Mangaluru and Padur. Okay, and we are also doing partnership with with countries such as UAE, which will provide oil to India for these strategic storages. Then guys, after this, there was a further government decided that we are also going to go forward with the other strategic reserves also. For example, in 2017-18 budget, it was approved that in Chandi Khole in Odisha and in Bikaner in Rajasthan, there will be additional 2 strategic oil reserves will be started. Okay, so in total we got 5: Vishakhapatnam, Mangalore, Padur, Chandikhol, Bikaner. So we got 5 locations, and recently, that is in 2021, government had said that basically capacity of Chandikhol and Padur will be enhanced. Capacity of Chandikhol and Padur will be enhanced. So in number wise, we have 5 locations. Number wise, we have 5 locations. Then moving on to the next one, that is natural gas. Now guys, when we talk about natural gas, major constituent of natural gas is CH4, that is methane. Now, when we talk about methane, guys, methane at the same time also happens to be a major greenhouse gas also. But still, country is moving towards natural gas because carbon footprint of natural gas is less than the coal. So basically, as countries are transitioning away from coal, so the transitionary fuel is natural gas, and then after natural gas, the countries might be moving towards a renewable energy. Now, guys, as we talk about the natural gas, methane. So natural gas is found into the hydrocarbon beds of coal as well as crude oil. So in conjunction with coal and crude oil, you can find the natural gas. Also, there are special type of creatures, that is the methanogenic organisms. They also produced methane. Actually, they are present even in the cattle, and they are responsible in production of methane in the cattle also. But this is very much negligible. Majority of natural gas that is commercially exploitable, viable, that is found in the seams of coal, crude oil, etc. Now, in India, we have natural gas across the west coast and east coast. So, Mumbai High, where we have crude oil, there we find natural gas also, and Krishna Godavari Basin, we find crude oil. Here also we have the gas. Now, natural gas, guys, there are certain related keywords that you should be knowing. So basically there is this wet gas. Now what is wet gas? So when natural gas is found along with the oil, it is called as wet gas. Then dry gas. When natural gas found alone, so natural gas reservoir that contains only gas, no oil, that is called as a dry gas. Coal bedded methane. When natural gas is found in coal, that is called as cold bedded methane. So wet means gas plus oil. Dry means only oil. CBM, coal bedded methane, means when the natural gas is found in the coal seam. Then sour gas. Sour gas is that natural gas which contains high hydrogen sulfide. High hydrogen sulfide. Sweet gas. Sweet gas is one which contains no or very less or very negligible hydrogen sulfide. Shale gas. Natural gas that occurs in the pores of shale, sandstone, or the sedimentary rocks. Okay. Then, so basically wet gas, oil and gas, dry gas, no oil, only gas, coal bedded methane. In coal seams, sour gas, high hydrogen sulfide, sweet gas, no hydrogen sulfide, shale gas, which is found in the structures of shale sandstone. Then critical minerals. Basically, critical minerals are those minerals which are very much important for the economic development of India, which are strategically very much important for industrial base of India. Now guys, basically when we talk about critical minerals, so India as of now has identified 30 critical minerals. 30 critical minerals. And who identifies these 30 critical minerals? Very important. So it has been identified by the expert committee under which ministry? Ministry of Mines. Which ministry? Ministry of Mines. Now guys, here the entire list of these 30 critical minerals I have provided, which includes beryllium, bismuth, cobalt, copper, gallium, germanium. You can just please go through this. I'll not advise you that you please buy heart. Just read this list 2 times. Also on critical minerals, this MMDR Bill Act 2023 was passed, where we have discussed that some of the atomic minerals, they have been denotified, and now after denotification, these atomic minerals have become critical minerals. They have become critical minerals. Now guys, when we talk about atomic minerals, so basically there were 12 atomic minerals. There were 12 atomic minerals that were identified by the government. Out of 12, 6 recently got denotified. 6 recently got denotified. Now, so we have 6 atomic minerals that we have. However, out of them, the most important is uranium and thorium. Uranium and thorium. Now, uranium and thorium are important because they can be utilized for production of electricity. Now, when we talk about uranium, uranium can be mined directly, but thorium, it is mined through the monazite and limonite. Now guys, good thing is that basically we have a lot of monazite in the sands in South India, particularly the Kerala coast. Lot of monazite is there, and from this monazite, thorium can be made. Now, in terms of uranium, we don't have too much of the reserves. So just 2% of world's uranium we have. 2% of the world's uranium we have, and largely uranium where it is found? It is found in Singhbhum. It is found in Singhbhum and Hazaribagh. Now, where are the Singhbhum and Hazaribagh? They are in Jharkhand. Jharkhand. Fine. Also, there is uranium that is found in Bihar. It is found in Bihar and Uttar Pradesh, Saharanpur. Uttar Pradesh, Saharanpur. But largest atomic mineral that we have, it is of thorium in the monazite sands of Kerala. Monazite sands of Kerala. Okay. Then after that, some of the atomic mineral find they are also find along with the copper mines. Further, when we talk about thorium, guys, thorium actually happens to be far more abundant, and even in the India's nuclear power program, we have 3-stage nuclear power program, and in the 3rd stage we are primarily going to use the thorium. Now, thorium in India, we have already seen that major producers are Jharkhand. We have seen that major producers are Jharkhand, Bihar, Uttar Pradesh. At the world level, the major producers of thorium are US, Australia, US and Australia. Now guys, we come to rare earth elements. Now see, the name is misnomer. Rare earth elements actually don't mean that they are rare. They are quite abundant, but their concentration in few packets or their concentration at one place is problematic. Therefore, they become rare. Okay, now when we talk about rare earth elements, they are actually 17 elements divided in 2 groups. That is lanthanide group, in which we have 15 elements, and scandium and yttrium. This is the group 2. So 15 lanthanides and scandium and yttrium. These are 17 rare earth elements. This list is given here. You can just download it. Now, when we talk about India, India actually has world's 6% of world rare earth elements reserves, but our production is just 1%. And China is one actually which is producing most of the rare earth elements, and at one point of a time 90% of rare earth elements are being produced by China. Now China is producing around 60% of rare earth elements. Now these rare earth elements, they have a lot of application in electronics industry. It has a lot of application in renewable energies, defense. So therefore, countries controlling these rare earth elements plays a very important. They have one important strategic lever in their control. Now, in context of India, when we talk about rare earth elements, so largely rare earth elements, they are located as a placer deposit. Placer deposit already we discussed. So they are largely they are located in Kerala, Tamil Nadu, Odisha, Andhra Pradesh, Maharashtra, and Gujarat. And majority of rare earths that we have here. Now you see this thing that in rare earth there is in rare earth we have neodymium that's provided here. Now it is in the lanthanide group, and after neodymium we also have praseodymium. Now in India we largely have neodymium and praseodymium. Okay, and Bureau of Mines and Department of Atomic Energy has largely carried the exploration of rare earth elements. Okay, and also guys, PSU, that is IREL, under the Department of Atomic Energy, has also been involved in the mining and exploration. So this is guys all about the minerals, and I don't think that anything you will be needing after this content. So that is all guys from my side. I hope guys that you have liked the video and you are appreciating the hard work that we have done. If you have liked the video, please do hit the like button. Subscribe to the channel. Thank you so much.